Again to another lecture in the Experimenting with Archaeology unit. Today we're going to do experimental archaeology, how it's done, what it is and why it's important. But before we get to that, as always, we acknowledge country, we acknowledge those Noongar, Whadjuk traditional owners, past, present and future, on whose land we stand. And indeed this whole unit is designed to deal with numerous different stakeholders, including Indigenous people, and how to manage their various expectations of archaeology and how we can work accurately, safely and in interesting ways. Righto, so let's crack on. So experimental archaeology. Experimental archaeology is a fascinating field. It's one of those things where you have to say, don't try this at home. It involves fire, it involves sharp stone tools, flying bits of glass and stone, it involves heating and breaking things, it involves axes, it involves quite a lot of making rafts that often sink. So don't try this at home. Rather try it at our experimental farm under controlled conditions. But it's a lot of fun and it's essential to hypothesis testing and to understanding how people in the past did what they did. But before we get to that, just a quick recap of the last lecture about field methods. So this is something every archaeologist does. We go out, we do survey, we map, and we make sure we have a central datum to which all our mapping points and data points relate. Sometimes we might excavate. We go and we record in-field data in various ways. Some of them are remote, some of them are direct like excavation, some are remote like ground-penetrating radar. While we're doing this, we have to think of the conservation potential of what we're finding and how best to conserve those artifacts and sites, and that happens right from the get-go and can continue for many years after the initial fieldwork. Always we have various publics and stakeholders that are interested in what we do and are often part of the teams in which we work, everyone bringing something a bit different to the table, and we have to manage all of those different people and their expectations. And then if you refer back, we did the Walyabook case study. Today our lecture structure is pretty simple. What is experimental archaeology? Why is it necessary? There's a quick note on use, wear and residues, which are an interesting and important part of experimental archaeology, or point us one of the starting points of experimental archaeology without being experimental archaeology themselves. Then I'm going to run you through 4 case studies on stone tools, on spear throwers, on rock art from Peshmel, and on the fantastic garbage project by Bill Rathje, and then conclude with some thoughts on how this work is useful not just to archaeology but to the world around us today. So in the photograph on this lecture structure side, we have, this was taken in 2017 at La Trobe University. They have an experimental archaeology farm, as does UWA, and over here people are busy making stone tools. What they've done is they've actually had a potter produce a porcelain core. Porcelain has a nice structure, a bit like stone but purer, so that the flakes that come off when you strike flakes for making stone tools come off quite nicely and produce beautiful flakes like they have over there. Alrighty. Obvious question, but it's always good to start at the basics and be very clear about what it is that we're doing. So what is experimental archaeology? So I'll just read this off because it's worth digesting. Experimental archaeology is a systematic attempt to test and or generate archaeological hypotheses through engaging with the materiality of the archaeological record. In other words, we use modern-day experiments to test hypotheses about patterns observed in archaeological data. So that's quite a mouthful. Let me break it down for you a little bit, starting from the end bit. So patterns in archaeological data. Archaeology is essentially pattern recognition. We go out, we survey, we excavate, we do all the different things we do, and we notice things about the archaeological record, all of those bits and pieces that have survived from the past. Remember, most of the past does not survive, just the durable bits survive. But even those durable bits that survive, partial as they are often part of a pattern. And we want to explain that pattern. How did that pattern come about? And that pattern is based on the materiality, on the evidence itself, the stuff. So as you can see here again from the La Trobe body farm, this was an honours project of Kim Crabtree, where she put a number of animals into cages and wanted to see how they decayed. Because one of the things we want to find out in archaeology is what do people eat? Plants, animals, and those sorts of things. The problem is, just because you find animal bones in a site doesn't necessarily mean that people brought them there. Other animals could have brought them there. An animal could have died naturally in a site. So we need to do this experimental work over here. In this case, it's in a controlled experiment where other little critters can't get to it in its mesh cage. But we're looking at the materiality, the bones. We want to see, well, what happens to these bones? Interestingly, in this case, after a year, the emu, and you can see an emu down here, the feathers had hardly decayed at all, whereas in the case of the macropods, they were intact, but all of the flesh had decayed off. So what we want to do is we want to take seriously those artifacts from the archaeological record, recognize the pattern they're part of, and start generating a number of ideas or hypotheses about how that pattern came about. So these are mental constructs based on the material record, but we want to test these mental constructs. And the way to do that is through experimental archaeology. So we say, right, if this was an animal butchered by people, what would we expect to see? We'd expect to see things like cut marks at certain places where the muscle attachments are there with the bones, that it's been defleshed. But there could be other things that produce marks in animal bones. And so what we need to do is then take animal bones and put them in a number of different contexts, let them decay naturally, do some butchering, have animals gnawing at them, all of which will produce different marks. We then compare those marks to the archaeological record to see if we've got a match. If we've got a match, then we're in the ballpark, in the business of explaining how things might have happened in the past. So if you look down at this slide over here, over at Stonehenge, so one of the great archaeological wonders of the world, and people have wondered how on earth did people transport these huge stones, sarsen stones, from Wales and other places over long distances and build this amazing monument. And so a number of experimental archaeology experiments were conducted on rollers, by ship, all sorts of different things. This has in turn informed the interpretation and the visitor centre at Stonehenge. But archaeologists were basically saying we have to explain how stones got from there to there. There are a number of possible ways they could have done it with Neolithic technology. Let's test each of those ways and see which one works better. Similarly, this book, which is all about fire, people were saying, well, very often archaeological sites, particularly huts and those sorts of sites, burnt down by either natural causes or by warfare or accidents or those kinds of things. And you normally think of fire as something that destroys, but in fact fire also preserves. So wood that burns, obviously it becomes charcoal in many cases, ash and charcoal. But where it becomes charcoal, number one, we can date that using things like radiocarbon dating, but we can also thin section the charcoal and see what kind of tree or wood it was, and then reconstruct the paleo environments of the time. For example, if it's an oak tree, you know it comes from a certain kind of forest, or if it's a more drought-adapted tree, you might infer that the climate at the time was more dry. And also, when things burn, different substances burn at different intensities and different rates. So by burning a whole lot of stuff, a whole lot of things down, we better understand whether something was burnt down naturally, which parts preserve, which parts don't preserve. And so what we see in the archaeological record, we understand what are called taphonomic factors, the various things that have happened to that artifact since it was made through to the moment of us recovering it archaeologically. You can think of this as an artifact life cycle, and a single artifact can have a number of different uses. Experimental archaeology is then useful in peeling away the different layers and finding out what those different uses were. So we have controlled experiments that give us known results that we apply to observed patterns in the material archaeological record. So I hope that makes sense. We do a lot of experiments to try and explain what we're seeing. We were not in the past, we did not observe it directly, so we can't say for sure what happened there, but we can try and experiment to see what had happened. So that's experimental archaeology. The next slide shows what experimental archaeology is not. So sometimes you'll go to essentially archaeological theme parks. That's a product of experimental archaeology, but by itself it's not experimental archaeology. Some of these theme parks are not based on scientific evidence. They are built as people thought they might be built. Others are based on experimental archaeology and formed by proper methods. So here you have the award-winning West Stowe Anglo-Saxon village reconstruction. Archaeologists found things like the post holes, and the village had burnt down. So the angle of the post holes plus the burnt debris enabled them to reconstruct what the houses are likely to have looked at. They're very sure what they looked like around the bottom, the paving, the post holes and things, but exactly how the thatching and such like went, that's a little bit of conjecture. It's informed hypothesis testing, but there could be a number of other solutions to the thatching, for example. But this is a pretty good reconstruction. A debatable example is the very well-known Kontiki and Ra expeditions of Thor Heyerdahl, controversial character who also robbed graves in Polynesia. Thor Heyerdahl had an hypothesis with Kontiki that people from South America could have settled Polynesia. So in order for them to have done this, obviously they would have had to have travelled across the water from South America to Polynesia. And to travel, you need reliable watercraft. So he then built out of reeds and a balsa wood. The Ra expedition was out of reeds, out of papyrus. He built out of balsa wood a raft and sailed it across a large part of the Pacific. This wasn't really experimental archaeology, though it did open us to the possibility of colonization of Polynesia from the Americas, but it was more a bit of a boy's own adventure. It wasn't done by an archaeologist, careful notes weren't kept, there wasn't really a proper set of hypothesis and testing. So experimental archaeology is not historical reconstruction or enactment, although that good historical reconstruction or enactment follows from good experimental archaeology work. The two sit together, but the one, experimental archaeology, comes before the other, historical reconstruction or archaeological reconstruction. Right, so why do we do this? Just to recap this again, we want to test our hypotheses. We can't just test them mentally, we need to test them materially. Again, it's the archaeological record, and see if we have a good fit between our experiments and what we're observing. This in turn then makes us understand the very materials people have worked with. Most of us have not made stone tools, have not built a hut, have not butchered an animal, for example. So we don't really know what that all involves. Experimental archaeology takes you through those steps, takes you through the activities that would have been performed by people in the archaeological past. And that then in turn helps us to better understand what was going through the minds of these people, why they chose certain plants, animals, materials to work with. Is there something about the flakeability of certain stones as opposed to other stones that made people more partial to one lithic source rather than another lithic source? So we're really trying to get into the minds of people through the things they left behind. So we've got minds back here in the past, we've got the things they left behind in the present, and connecting the two are the experiments we conduct and the hypothesis we think up. And sometimes, and I'll get to this at the end of this lecture, this can have some real-world applications to us today. So it's a very exciting, fun, but necessary field. It was made famous by the processual or new archaeologists of the 1960s and 1970s because they really understood that we didn't understand the materiality of the past, how people did what they did. So they really wanted to get into it, get their hands dirty, and do a whole lot of experiments. 2 slides now on use-wear and residues. So use-wear analysis and residue analysis are not by themselves experimental archaeology, but they're very often crucial starting points for experimental archaeology. So use-wear and residue work on Locard's principles. So Locard, who I believe was a criminologist, but anyway, Locard's principle is that every contact leaves a trace. So a fingerprint leaves a trace. In theory, everything leaves a trace, at least at a molecular level. Of course, sometimes subsequent uses can erase previous uses, and sometimes taphonomic factors such as a site being waterlogged or very acidic or something like that means that traces won't typically be preserved. But every now and again we find things, and increasingly archaeologists, when they're doing excavation and collection, are doing things like wearing gloves for DNA analysis, another sort of trace, and they want to preserve the use-wear and residues that we have. So use-wear are the marks left by the activity of a tool. So a stone tool used to cut wood will have different marks on it from a stone tool used to cut the flesh of animals or to process plants, for example. Residues are those bits and pieces that are left behind on that tool. So that same stone tool could have minute traces of blood that goes into the cracks, the minute cracks in stone tools. These can last, believe it or not, up to 60,000 years under the right conditions. A Canadian researcher came to live in Australia, Tom Loy, pioneered this field and found that residues can exist for a very long time. You can get starch grains on grindstones that exist, for example, in Cuddy Springs for over 20,000 years, giving us clues as to people's subsistence patterns. And then understanding the use-ware is important. But of course, if you just find a stone tool that has different marks on it, you don't know what those marks were made by. You need to conduct experiments with stone tools on a number of different substances, wood, stone, plant, etc., and then compare the marks from your experiments with the marks on that stone tool and see what's the best fit. Sometimes you'll get more than one mark, but sometimes you'll have a stone tool that is used for only one purpose, and you can say, right, that was used to process hides, or that was used for wood whittling and working. So the two exist hand in hand. Down here what you can see is just some pottery that's been found. So it's pottery found in Italy, 3,500 year amphora, and on the inside of the pottery there were traces of what used to be in that amphora, and in that pot used to be wine. So what you're seeing over here in terms of this chemical analysis over here are the different bits and pieces of what's there, but it shows that wine was produced in Italy 3,500 BC, for example. So something we didn't know before use-ware and residue, especially residue analysis, was done in this case. Fascinating example. Here's a recent example, so from Europe. So what we have over here is we have Neolithic people in Europe and looking at their subsistence tools. So this is the scientific article in the journal Antiquity, and you can see the proper referencing of it here, as well as the digital object identifier where you can go read the full article. But there's a précis over here, and I'll just go through it with you. So this was the archaeological find, the artifact that was found, and it was studied very carefully and found to have a residue on it. So let's just read. Northern Europeans attached a barbed bone point, i.e. this, to a handle of some kind. The handle has since disappeared. It's probably wood and it's decayed away. But it has, at the point of attachment, a kind of beeswax adhesive. And this is dated at 13,000 years ago. Beeswax is organic, so you can date both the beeswax, you can also date this bone point, and you can date the archaeological layer in which they occur. Now we know that this is not the oldest such example in the world. As they say here, using beeswax glue to make tools was common in Africa as early as 40,000 years ago, and they give a reference here for that. But this spear is the first evidence of its use in the cold parts of Europe. So we know 13,000 years ago it was pretty cold in Europe, where people were just coming out of the last glacial maximum about 18,000 years ago, or the Ice Age. There's still questions. Where the beeswax came from remains a question. Honeybees, and here are some hypotheses they moot to explain the beeswax. Honeybees may have pushed north into Europe from warmer Mediterranean locales several thousand years earlier than was thought. Or Northern European hunter-gatherers may have obtained beeswax through trade extending into the Mediterranean. This is the key part now. New chemical and microscopic analyses of the bone point, which was discovered in Western Germany in the 1930s. So it's been sitting in a collection for 90 years, but we now have new technology and new questions to ask of these old objects. And it identifies there's beeswax mixed with crushed charcoal. And they reckon from experiments that the charcoal keeps beeswax from becoming brittle, they suspect. So this is a hypothesis. They now need to test it. So they're now going to need to test beeswax on its own with charcoal and with other substances, and to see how it hafts, because obviously if you've got a brittle substance joining your fishing spear, it's going to break very easily. And the next part of this project is to conduct a whole lot of beeswax experiments. Pretty neat. So use-ware and residue are often starting points for experimental archaeology. Right, let's get into our case studies. So number one, we have stone tools, one of the most common examples of archaeological artifacts that survive until today. But we just get the stone tools. If I go back, just like with this bone point, the long haft that came with it doesn't survive. We've just got a part of it. And a lot of stone tools were also composite tools that were hafted in spears, bows, and other tools, digging tools and so on. So what we can do is we do have examples of people in the world who still use stone tools. Well, we ourselves still use stone tools. Granite countertops, computers all have silica in them. People who smoke cigarettes have cigarette lighters have a little flint in. So we're still in the Stone Age in some ways. But there are still societies that make stone tools by knocking them, flaking them off rocks. So over here, a Hadza woman, the Hadza from East Africa, in the 1990s, there was a study done among the Hadza to see how they use stone tools to work hides. So this white thing over here is an animal hide. She's making stone tools as scrapers to scrape that hide. So the archaeologist looked at two things. How does she make those stone tools so that we can compare with what we think, in this case, Cro-Magnon or Upper Paleolithic European people use stone tools for, and then what residues and use wear are on the stone tools, again, so that we can test and compare with archaeological samples to see if we can see traces of those same residues and to see if we can see the same kinds of use wear marks. So you work from the known, which is in the present, to the unknown in the past, and see what is the best fit between your observations, experiments, and the archaeological reality. In Germany, they had this experiment on the go. So the Neolithic people, with a lot of their farming, were thought to have felled large areas of forest to clear land for their crops. And it's thought that adzes, these stone tools that are hafted in this big composite wood, leather, and some sort of binder, organic binder, that these tools were the ones that chopped the trees. It's a reasonable guess or hypothesis, but it has no evidence to support it as yet. So let's run through how they went about testing that. So experimental tree felling with reconstructed adzes of archaeological finds of the linear pottery culture of about 5,600 to 5,000 before the Common Era in Eggersheim in Germany. So they kind of knew what these looked like or could reconstruct them. In some cases there were waterlogged finds where you had an almost complete adze. They reconstructed modern examples. We're not using archaeological examples. And then what they do is they very carefully scan and mark both tree and adze. The tree has reference marks and was 3D scanned with the laser total station. So as they're chopping away with the adzes, you're scanning the tree so that you have a 3D digital model of the different marks the adze is making. And then what you do is you look at stress marks on the adze. So when you look petrographically at stone, when you look at it to see where little fracture and stress marks are, and what they call the ghost lines on the tree stump, you're able to match those up, in this case, with archaeological adzes that had very similar marks. So we're very confident in this case that the adzes were used to fell trees because they have the same use wear and stress marks as trees do. So in other words, archaeologists observe a pattern in the archaeological record, stone adzes and wood with distinctive marks. They formulate a hypothesis that can account for these marks. In this case, they said maybe it's tree felling. You then reconstruct the adzes, fell trees, and analyze and compare the marks of the known archaeological examples and the reconstructed tree felling adzes. In this case, you had a very close match, so the hypothesis is confirmed. There could be some cases where the hypothesis is not confirmed, and you then have to think of another hypothesis and another set of experiments to conduct in order to try and confirm it. Confirmation is always provisional because there could have been multiple uses, and it could be that similar stresses and impacts could be caused by a number of different activities. But still, our knowledge is improved, and we're on a much more scientific footing that other people can look at, they can test, and they can take further. All right, second case study was one that came up in the 1900s in Europe. So shortly after Europeans realized how old the world really was, and a rational scientific way of explaining the world took over from essentially a divine causal way of understanding the world. One of the finds in Upper Paleolithic French caves in particular were these beautiful bone artifacts. So you can see a deer here. Here's its head. It's looking over its shoulder. There its ears, there's its snout, here its front legs, body, back legs, tail raised, and in this case there's a little bird on the top. And this is out of ivory, and then it has this long decorated baton with these holes in it. And other fragments of these have been found over here. And people didn't know what these were used for. So initially they said this was a very beautiful object, and it looks like a very powerful object. It's on a rare material. This must be a baton de commandement, a baton of command or authority. This must have been an important leader-type figure in that hunter-gatherer group, and this was a symbol of their authority. The problem with that notion is it wasn't tested, and the hypothesis was informed by modern non-hunter-gatherer notions of kingship and queenship and symbols of authority. Once archaeologists started looking at the archaeological context in which the artifact was found, and also starting to look at the use where they said, oh, there could be other possibilities here. These holes, for example, showed use wear marks that are consistent with straightening spears, straightening wooden spears. So they could be spear straighteners. And then others said, using ethnographic analogy in Australia, figures here in a moment, is they said these could be spear throwers. These are things that you use in order to increase the velocity, the speed, the penetrating power of a spear. And the next slides might make this a bit clearer. So what people did is they looked in Australia at spear throwers, or woomerers as they are sometimes known, at museum collections. So here's a woomerer. You can see a little point over here. So if we go back, imagine a spear where the base of the spear is placed here and the rest of the spear goes this way with the point being here. So you would hold this horizontally. The spear would be in that hooked area, and you would then use the woomerer to throw the spear. So in other words, if you look at this Aboriginal man over here, and this is an authorized photo, he's got this very long spear that goes there, but he's not really holding the spear, he's just guiding it with his finger. He's holding one of these, a woomerer. He's holding that, and that little sharp point over there nestles at the base of the spear. So when you use this to throw by leverage, it really increases the speed of and accuracy of the throw. Here you can see again, here's a modern reconstructed example. So let me go back. So what people did is they tested the hypotheses that, is this a baton de commandement, or is this a spear thrower or woomerer or atlatl? It has different names on different continents. And they looked around for examples in the world, and one of the places was Australia, another place was North America among Native Americans, where they saw known ethnographic examples of people using spear throwers. So this type of artifact certainly can be used as a spear thrower. So that's using analogy. You're comparing a known culture with and use with an archaeological artifact. You compare the two. The other way to compare is through experimentation. So what you do over here is you construct for yourself a number of spear throwers, and you then try and throw spears. And lo and behold, there are lots of articles. Here's an early one from the 1960s. Lo and behold, there are all sorts of different kinds, but people found that these vastly increase the power and accuracy of throwing a spear. And it's a multifunctional tool in many cases because it also has a sort of built-in straightener. So in this case, experimental archaeology discriminated between two different hypotheses as to what something could be used for, as a symbol of authority or as a spear thrower, and said the evidence shows mainly that it is a spear thrower. Of course, spear throwers like this are very beautiful and they can have other symbolic meanings, but they certainly were used as spear throwers. The next example is a related one, our third case study. There's a painted cave in France. We're having a bit of a French festival today. We've got lots of Australian examples, but this one too has an Australian link. And there's a cave called Peshmel. You can visit this. It's open to the public, and it's known for having these beautiful so-called Chinese ponies or horses. A whole lot of hand stencils, all sorts of dots. You'll notice how the rock goes over here is almost in a pony shape. Remember, this is a cave fairly deep underground, and it's pitch black dark. People would have had to, when this was made 24,000 years ago, if memory serves, they had to have little tallow lamps, and they would work in a very dark environment with lamplight. They had to get their pigment organized. So painting, people forget that in order to paint, you've got to go and make your paint. In order to make the paint, you have to get different bits and pieces together. You need a binder, you need a loader, you need an extender, you need the pigment. You might put extra substances that have symbolic merit, snake venom to show a dangerous painting, for example, who knows. But it's quite a complex exercise in chemistry and in physics to paint these. And people have said, well, these are very beautiful paintings. It must have taken years and years for these to make. But then a French archaeologist, Michel Blanchet, who you see over here, he's had to think about it, and he said, no, he doesn't think they take very long. Not because they're easy, but because people were skilled. And he set about, in a non-archaeological cave, replicating the Peshmel horses. And he found that in about 24 to 32 hours total, you could produce this beautiful frieze of rock art using traditional methods. And at this point, I'm just going to skip to a little YouTube video that Brown University have put together on the Peshmel experiment. It's over there. And it's about 5 minutes long, 5-6 minutes long, and it quite nicely creates the intellectual context of the time as well as how Laure Blanchet went about his experiment. So enjoy this.
Southwest France has a long history of habitation. 30,000 years ago, Cro-Magnon, now thought early European humans, lived there. They were people like ourselves. They lived in caves, made stone tools, and hunted animals for food. Some painted pictures on cave walls. The paintings are found in seemingly special caves, distinct from their habitations. They painted the animals they saw and hunted: deer, aurochs, mammoths. Sometimes they painted humans, and occasionally abstract signs. We can only attempt to interpret these paintings. They may be part of a religious experience with the purpose of ensuring good hunting. They may simply be natural artistic expression. The cave of Pechemel near Cabaret is one such cave, and is one of several painted caves in the vicinity. The paintings were discovered in the 1920s by 15-year-old André David, a local shepherd who had been exploring the cave for several months. The local priest was a prehistorian, so the discovery was recognized quickly. The abbé realized the importance of the discoveries and started to document them. The land was bought by the commune, galleries were widened, and a new entrance built. In 1924, the caves were opened to the public. Here we see the newly opened cave with the abbé and some young visitors. The caves contained over 700 individual depictions. We know that men, children, and probably women came into the caves. Some of the hand paintings are small and must have come from children's or women's hands. A young child's footprints were also found fossilized on the floor of the cave. So what are the famous spotted horses? Recently, DNA research found that prehistoric horses could have been spotted, and led to reports that these paintings could be naturalistic representations. Well, actually, it isn't that simple. It isn't just the horses that are spotted. The horses are surrounded and covered by spots. This picture shows the outline of the horse. Note where the spots are. The horses' heads themselves are quite small, as can be seen in this section. Why spots? One can only speculate. However, there are spots on several other paintings. The horses are not the only paintings on the slab. They are painted over earlier paintings. For example, there is a large red fish, possibly a pike, painted under this horse on the right. At the moment, scientists can only date a tiny part of the painting. Most of the paints are manganese or iron oxides. Neither can be dated with carbon-14. However, there are some small areas where charcoal was used for drawing. This was dated at about 25,000 years before the present. Presumably, the underpainting fish is older. Other paintings in the cave have been dated to 16,000 before present, so the cave was being used for paintings for many thousands of years. One archaeologist, Michel Laure Blanchet, has spent many years studying these and other cave paintings. Laure Blanchet, who grew up a few kilometres from Pechemel, visited Australia and spent some time with Aboriginals who were still producing cave paintings. In some areas they used frayed twigs with brushes, but in Queensland, where the rocks were very uneven, just like the rocks in his home territory, they used a spitting technique. He recalled, "In Queensland, I learned how people painted by spitting pigment onto the rock. They spat paint and used their hand, a piece of cloth, or a feather as a screen to create different lines and other effects." Could these techniques have been used to paint the horses? Returning home, Laure Blanchet found a suitable cave in which to produce his own copy. His only concession today was to use wood charcoal rather than manganese oxide. Experts told him that manganese oxide was toxic, producing psychotic behaviour and hallucinations. He followed the techniques used by the Aboriginals, grinding charcoal from the fire and using iron oxides from the soil. He mixed them with saliva to form a paint of the right consistency to spit. He made a sketch using a charred stick, and then got spitting, shaping his hands as a stencil to direct the lines. Dots could be made perfectly using a piece of leather as a template. It took him 32 hours to paint this copy of the spotted horses. Painting the horses gave him some insight into how the original artists might have felt. In his book he writes, "I spent 7 hours a day for a week. Puff, puff, puff. It was exhausting, particularly because there is carbon monoxide in the cave. But do you experience something special painting like that? You feel you are breathing the image into the rock, projecting your spirit from the deepest part of your body onto the rock's surface." Maybe this gives us some clue as to why the earliest humans painted these images.
Right, so that's a great example of experimental archaeology. Right, so the Peshmel example is a great example of how when you look at this YouTube video, it's a great example of how experimental archaeology puts you into the mind of people who came before.
Southwest France has a long history of habitation. 30,000 years ago, Cro-Magnon now thought early European humans.
So have a look at this at your leisure.
There were people like ourselves.
But the Peshmel example is a really good example because what it shows is, if I can just find the lecture again, there we go, is it shows how Michel Laure Blanchet, going to Queensland, studying Aboriginal people's painting techniques now, the spitting technique that they used, that technique could have been used. There was no contact between Australia and France back then, of course, but that is a technique that hunter-gatherers could have used to produce the Peshmel cave. Like they say in the video, it took him 7 hours a day for a week to produce a replica of Peshmel. He didn't use the manganese dioxide because that can produce hallucinations and psychotic behavior, but he did experience the carbon monoxide that was being produced, and he did experience a kind of spiritual bond, as the video says, how he breathed. He felt he was breathing his spirit into the rock. That is impossible to test whether people in the past thought so, but it is starting to help us explain why people thought what they thought. It certainly explains how the paintings were made at a technical level, and it goes some way to understanding how the paintings were made, conceptually by people, what they thought they might mean. Right, so Peshmel, let's move over to North America. So we've had stone tools, we've had spear throws, and we've had rock painting. How about garbage? This is a case study I like and use often. There's an archaeologist, unfortunately he's passed away now, Bill Rathje. He worked at the University of Arizona and then later at Stanford University. And he said, well, a lot of archaeology is essentially the study of rubbish. Rubbish is a very informative source of evidence of where we all come from and what we all do and what our habits are. You know, all those things you throw away, all those secrets you throw away in the trash, well, archaeologists will probably find them. You won't be embarrassed because you'll probably be dead by then, but it's all there. And sometimes, like today, we have these huge rubbish dumps that will constitute an important part of the archaeology of tomorrow. And Bill, who was a Mesoamericanist, he studied Maya, Aztec civilizations. He said, but hang on, in archaeology we operate on uniformitarian principles. So the way in which, for example, an ancient shell midden forms and the way a modern garbage dump forms in different layers of materials that are perishable and imperishable should be the same. The laws of association, the laws of uniformity should apply in the same way. And we can do lots of things like do relative and absolute dating. So many of you will maybe not be familiar with the ring pool cans. That's because mostly ring pool cans in most parts of the world in the mid-80s gave way to the tab pool cans that we have today. The ring pools were people cutting their feet on it. It was affecting wildlife. So if you find one of these ring pool cans, you know that it's unlikely to be more recent than the mid-1980s, and you can do some relative and absolute dating, even though it's a modern artifact. But how the garbage project started was as a student and public health exercise. So in 1973 at the University of Tucson in Arizona, Bill Rathje was approached by people in the sociology department who said to him, they have a problem. They're interviewing people in a certain part of town, a lower socioeconomic status part of town, and they think people are drinking to excess there, and they would like to be able to institute a number of measures to curb this alcoholism, but they need the proof in order to do that without necessarily embarrassing anybody, but to apply for federal funds. But when they, as sociologists, go to the front door, knock on the front door and say, hi, how are you doing? This is who I am, this is what I'm doing, and they get consent to do the interview, they then ask the question, how much do you drink each week? Now you can imagine each of us, those people who drink, if you are asked how much alcohol you consume per week, most people will probably tend to underestimate things. They will lie. And this is what happened. People said, oh, we don't drink very much. So Bill said, I can get you more objective data. We know where the trash from that neighborhood is dumped in the rubbish tip, and we can go and look at it. So he got a bunch of students together, and they got two things, a tetanus injection and a thick pair of gloves, and they went through the trash. And they did some rough quantification exercises on how many alcohol bottles there were as to how many people lived in that neighborhood. And their findings were that people were consuming on average 15 beers a week, which was closer to the actual consumption than the reported consumption of 4 to 6 beers per week. So people saying, oh, I have 1 6-pack a week, whereas in fact they were having 2 or slightly more than 2 6-packs a week. There were other things. The study almost funded itself. They found $3,000 in coins, although that was from 600 tons of landfill. Fascinating. World War II, approximately half to 60% of household rubbish was recycled. People had to. It was a time of privation. There wasn't a lot going around. So people were recycling because they had to, and they did 50 to 60% of their household rubbish. Even their toilets went to a common septic tank, and the methane gas from that was piped off, then people could cook on that gas. Today we make a lot of noise about recycling, but typically 10 to 30% of household rubbish is recycled, if at all. Another myth that was exposed is that paper doesn't biodegrade. The reason for this is it's the volume of waste. The paper finds itself in these huge anaerobic blocks that are about as big as a city block. No oxygen comes in. So they just sit there and they don't decay. Bill Rathje's team was finding hot dogs from the 1930s that just didn't decay at all. Once they were exposed to air, they started to decay, but in the landfill they didn't. So there are important lessons about modern waste consumption, modern consumption and waste disposal habits from this archaeological experimental study. So this segues very nicely into the last part of this talk, which is how experimental archaeology helps us here today. So number one, it tells us what's really happening about our waste disposal projects. And you do have to be careful here. Bill Rathje was later approached by the US government that asked him whether he would be able to detect the presence of illegal Hispanic immigrants or migrants into North America, into the USA from Mexico and other places from waste dumps, small and large waste dumps. Bill Rathje, who's an ethical and conscientious archaeologist, said, yes, I could be able to do that, but no, I'm not going to do that because I don't know how you're going to use that information. He was saying, I worry that you, in this case the US government, will use that information against someone, and I don't agree with that. So there are often ethical implications to our work. But aside from our waste disposal habits, there are other applications. There are many of them that have come through experimental archaeology, and I'll just go through two. So first is farming. So what you have here is some farming in Peru, how an underpopulated area today in Peru has now become populated thanks to a productive ancient farming technique. So archaeologists, when we're excavating and recording in the field, we often get whole seeds and residues from which we can extract DNA, and we can see what the appropriate crops are for a particular region. crops that are resistant to drought, to monsoons, to all of these different things. We can then make better decisions about what we should be planting today. So in this case, an archaeologist called Clark Erickson, was working in Peru and had aerial photographs. Here on the left we have an aerial photograph, and he saw all of these oblong shapes. And when they went down onto the ground and looked at these, they realized that these were raised fields. So here is the experimental reconstruction on the right. What you have, these are the raised fields. These are the oblong shapes that are being seen. And these darker shapes are channels between them where water can flow. So to cut a long story short, this unique hydraulic form of agriculture is very productive in a part of the world. It's quite a high elevation here in Peru that today doesn't have much going for it archaeologically. But by bringing back this ancient technique, we now have 300,000 acres of raised fields that are producing food that are supporting a population. And this works often even in drought years. So a great example of how experimenting, using our knowledge of the past, how people were adapted to that past, we can use that to improve the present. And then here's a nice one, obsidian blades, stone tools essentially. So obsidian is volcanic glass. It occurs obviously near volcanoes and was highly prized. It's been made famous by people like the Mayans who performed various rituals with it, burials and such like. But today you can buy obsidian blades for medical surgery because obsidian blades cut more cleanly than even ceramic knives. So over here in an electron microscope, you can see this is the SEM, the scanning electron microscope profile of the obsidian blade, and this is of a steel scalpel. The steel scalpel, you'll see at the electron microscope level, is not nearly as sharp as the obsidian blade. The cleaner the cut, the faster you heal. And so as this doctor here, Lee Green, says, I like the obsidian knife because it traumatizes the tissue less. It is very sharp and very smooth at the microscopic level. So this is something that people were doing in the past. And in order to make an obsidian blade, you have to know how to nap stone tools. This is not a mass-produced factory thing. So an ancient technique and an ancient substance has been brought back into 21st century medicine. To reiterate the word of caution I was mentioning about the Department of Homeland Security and Bill Rathje's rubbish dumps, make sure that your experimental archaeology, it always has to be safe. We have all the occupational health and safety guidelines need to be in place. When you're making stone tools, there's stone chips flying everywhere. So you need some goggles, you need gloves, you need to protect your hands. Also, it needs to be ethical. How is the information going to be used? Are the materials you're using ethically sourced and so forth? And above all, it needs to be in the service of a research question or a hypothesis. You must be seeking to construct new knowledge through experimentation. So don't try this at home, but do come to our experimental farm at 73 Fairway and have a lot of fun with this. And that's all I have to say on the subject of experimental archaeology. There's a great deal more to say. There are many readings, which would be some of whom are reproduced down below here. It's a fun thing to do, but it's also a very informative way of testing our hypotheses, of understanding the past, and of getting into people's minds, of thinking like they did in the past, which is the really exciting part. That concludes today's lecture. Thanks very much.